Hello, Dr. Hall. So I will be working out problem number 8 from the midterm exam. So basically, as was pretty common, I ran out of time on the exam and wasn't able to do this one completely. I actually wrote down a couple of the formulas. I wrote down this formula here and this formula here as well. I was able to get 5 of the 20 points, but I was marked off 15. So this is what I'll be doing my rework for. So basically, first off, let's just read the question. A ball and socket joint at the end of a rocker arm. So we see the ball and socket joint right there. At the end of a rocker arm, there's the rocker arm, has a carbon steel spherical surface with a diameter of dB is equal to 10 millimeters. So that is the diameter of 10 millimeters. And this is carbon steel. Fitting in a phosphor bronze bearing alloy spherical seat, that is that, with a diameter of ds is equal to 10.2 millimeters. So from here to here, the diameter is 10.2 millimeters. Find the maximum force F, so that the shear stress from in the rocker arm from the contact stresses does not exceed 500 megapascals. Okay, so where do we go from here? So we're trying to find the maximum force F. So we're trying to find the maximum force F, and we have the shear stress. They've given that to us in the problem. So here we have the tau max is 500 megapascals, which is equal to 500 times 10 to the 6 pascals. We're also given the two diameters. D1 is dB over here, which is 10 millimeters, but we've converted it to 0.01 meters. We're also given D2, which is ds in the problem statement. That is 0.012 meters, but in the problem statement, it was given to us in millimeters, 10.2. So, moving on, there are 3 formulas that we know that we're going to use. A is equal to the cube root of 3 times f, there's f, remember, divided by 8, times 1 minus v1 squared, that's Poisson's ratio, divided by E1, the elastic modulus, plus 1 minus v2 squared, again, another Poisson's ratio for the second material, divided by the elastic modulus of the second material. All that divided by 1 over d1, the first diameter, plus 1 over d2, the second diameter. So that's one formula that we know we're going to use. The second formula we know we're going to use is tau max is equal to 0.3 times p max. Okay? So they've given us tau max already. So then the third equation that we know we're going to use, and this is really the money formula here, is p max is equal to 3 times f, again there's f, times 2 pi times a squared. Now a we get from this formula. So we're looking at this and we know that we need f and we have the tau max, right? So where we're going to go with this is that we've already been given tau max, so we know from there we can use that value to find p max, okay? So we're going to use this equation, tau max is equal to 0.3 times p max. So plugging the values in that we already know, tau max is 500 times 10 to the 6 pascals is equal to 0.3 times p max. So we use that formula, one unknown, to find p max, which is equal to 1.667 times 10 to the 9 pascals. So now that we have p max value, we're looking at this formula again, is we have p max, we need f, and we need a as well. Now, one thing that we can do here already, we can't find f yet, but we can find f in terms of a, okay? So, we're going to do that. We're going to find f in terms of a using p max is equal to 3 times f divided by 2 pi times a squared. So, plugging in the p max value that we have, 1.667 times 10 to the 9th pascals is equal to 3 times f divided by 2 pi times a squared. So, then we multiply the 2 pi a squared over to this side and divide by 3, and you get f is equal to 1.667 times 10 to the 9th pascals times 2 pi times a squared divided by 3 comes out to be 3.4913 times 10 to the 9th pascals times a squared. Okay, so here we have an F in terms of A, but we still need to find our A value if we're going to find that F. So what we can do is we can plug that value into the formula for A, and it will actually give us a value for A, okay? So, starting from there, find A is equal to, we've already went over that formula, and we start plugging our values in. 3 times F, which we just solved for in terms of A, which is 3.4913 times 10 to the 9th times A squared, divided by 8, times 1 minus, okay, so this value, the Poisson's ratio and the elastic modulus values, we got from table A5 for carbon, steel, and phosphor bronze. So in the problem statement, it gave us the materials, so we went to A5 to find the elastic modulus values and the Poisson's ratio values. Now you'll note that we actually had to convert those to pascals as well. So coming back into the formula for A, so we've got 3F divided by 8 here, times 1 minus the Poisson's ratio for carbon steel squared divided by the elastic module of carbon steel, which is 207 times 10 to the 9th pascals, plus, now we do it for the other material, 1 minus the Poisson's ratio for phosphor bronze, which is 0.349 squared. It's 0.349, and then we square that value. Divide that by the elastic modulus, which is 111 times 10 to the 9th pascals. So, we're going to divide all of that, divided by 1 over the first diameter, which is 0.01 meters, plus 1 divided by D2, 0.012 meters, okay? So, really long formula. Finally, after putting all those values in, remember it's A is equal to a cube root of all of that. So we're going to cube both sides, and this comes out to A cubed is equal to 8.2312, 10 to the negative 3 times A squared. There's where that A squared term came from. And the rest of that is just algebra to get 8.232 times 10 to the negative 30. So, basically, then we divide that out, divide the A squared on both sides, and you come out to A is equal to 8.232 times 10 to the negative thirds meter. So, now we have an A value, we have a P-max value, and we still need the F. F is what we're going for here. The maximum force, F, so that the shear stress does not exceed 500 megapascals. So, the last thing that we need to do is just algebra for the last step. So we need to find F. We already have F in terms of A. So now that we have A, we just simply plug the A value we just found into that formula that we came up with a while ago. F is equal to 3.4913 times 10 to the 9th A squared is equal to 3.4913 10 to the 9th pascals times the A value we just came up with, 8.232 times 10 to the negative thirds meter squared. And that comes out to 236,582.9607 newtons. Okay? Which then we can convert that to kilonewtons, and we get F is equal to 236.58 kilonewtons. Okay, that was a long, strange trip. What did we do there? So basically, again, we are finding the maximum force F so that the shear stress from the rocker arm does not exceed 500 megapascals. So using the three formulas, tau max is equal to 0.3 times P max. Using that, we found P max. Then we used P max is equal to 3F divided by 2 pi A squared. We used that to come up with a value for F in terms of A. Then we found A, and then we found F. Thank you very much.